Picture this. You're witnessing one of Earth's most explosive volcanic eruptions, when suddenly the ash cloud above begins crackling with electric fury. Lightning bolts tear through the darkness, illuminating the chaos below in an otherworldly display of raw power. This isn't science fiction, this is volcanic lightning, and it's one of the most spectacular and terrifying phenomena our planet can produce. Today, we're diving deep into the violent marriage between fire and lightning, exploring how volcanoes literally summon their own thunderstorms and create some of the most dangerous spectacles on Earth. Volcanic lightning, also known as dirty thunderstorms, occurs when electrical charges build up within the massive ash clouds that spew from erupting volcanoes. But unlike the lightning in regular thunderstorms, volcanic lightning is born from chaos itself. When a volcano erupts with explosive force, it hurls millions of tiny rock fragments, ash particles, and gas into the atmosphere at incredible speeds, sometimes reaching over 100 miles per hour. These particles are traveling so fast and colliding with such violence that they create static electricity on a massive scale. Think of it like rubbing a balloon on your hair, but magnified by millions. As these ash particles tumble and crash into each other in the volcanic plume, they exchange electrons. Larger particles tend to become negatively charged, while smaller ones become positively charged. This charge separation creates the perfect conditions for lightning. But here's where it gets truly incredible. Volcanic lightning can be far more intense and frequent than regular lightning. We're talking about hundreds of strikes within minutes, creating an almost continuous electrical storm above the volcano. The science behind volcanic lightning is still being unraveled by researchers, but we know it involves several fascinating processes working together. First, there's triboelectrification. That's the fancy scientific term for static electricity generated by friction. As billions of ash particles collide at high speeds, they create massive electrical imbalances. The turbulence within the eruption column acts like nature's most violent washing machine, constantly mixing and separating these charged particles. But there's another player in this deadly game: ice. At higher altitudes, water vapor in the volcanic plume freezes, and these ice particles also become electrically charged through collisions. This process, similar to what happens in regular thunderstorms, adds even more electrical potential to the mix. The temperature differences within the eruption column create powerful updrafts and downdrafts, further enhancing the separation of electrical charges. Hot gases rise rapidly, while cooler, denser material falls, creating a massive electrical generator in the sky. What's remarkable is that the intensity of volcanic lightning often correlates directly with the explosiveness of the eruption. The more violent the volcanic activity, the more dramatic the electrical display becomes. Throughout human history, volcanic lightning has inspired some of our most powerful mythologies and religious beliefs. Ancient civilizations, witnessing these incredible displays, created elaborate stories to explain what seemed impossible. Mountains that could command the heavens themselves. The ancient Greeks believed that Zeus, king of the gods, forged his lightning bolts in the fires of Mount Etna. When volcanic lightning crackled above eruptions, they saw it as divine intervention, the gods themselves participating in the Earth's violent transformation. This wasn't just poetic imagination. They were witnessing real electrical phenomena that science wouldn't explain for thousands of years. Norse mythology tells of Thor's hammer creating both thunder and the fires beneath the earth. Vikings witnessing volcanic eruptions in Iceland saw the lightning as Thor battling the fire giants. A cosmic struggle played out in ash and electricity. These weren't primitive superstitions. They were sophisticated attempts to understand genuinely supernatural-looking phenomena. In Japanese mythology, dragons were believed to control both volcanoes and weather. When Mount Fuji or other Japanese volcanoes erupted with lightning displays, ancient observers saw it as evidence of these powerful creatures unleashing their fury. The serpentine shape of lightning bolts through ash clouds does bear an uncanny resemblance to the dragons of Asian art. Central American civilizations developed complex mythologies around volcanic lightning. The Aztecs believed that Tlaloc, the rain god, and Xiuhtecuhtli, the fire god, would sometimes join forces during volcanic eruptions, creating displays of divine power that demanded human sacrifice and elaborate ceremonies. What's remarkable is how accurately these ancient mythologies captured the awe-inspiring nature of volcanic lightning. While we now understand the scientific mechanisms, the sense of witnessing something beyond ordinary natural phenomena remains unchanged. Moving from mythology to recorded history, volcanic lightning has created some of the most photographed and terrifying natural disasters on record. Witnesses of the 1980 eruption of Mount St. Helens reported lightning of up to 2 miles long, although the photo and video documentation of that lightning was limited. But perhaps no volcanic lightning display has been more widely witnessed than Iceland's Eyjafjallajökull eruption in 2010. This eruption didn't just ground air traffic across Europe, it created a light show visible from space. The combination of Iceland's clear air and the eruption's persistence gave photographers and scientists unprecedented opportunities to study and document volcanic lightning. Japan's Sakurajima volcano provides us with regular volcanic lightning displays, sometimes producing dozens of strikes during a single eruption. This active volcano has become a natural laboratory for scientists studying the phenomenon. One of the most visually stunning displays occurred during Chile's Calbuco volcano eruption in 2015. The lightning appeared in brilliant purples and blues, creating an almost surreal landscape that looked more like a scene from an alien world than our own planet. While volcanic lightning creates breathtaking visuals, it also amplifies the already severe dangers of volcanic eruptions. Lightning strikes can ignite fires in areas already struggling with ashfall and volcanic gases, creating additional hazards for evacuation efforts and emergency responders. The combination of volcanic ash and lightning creates a double threat to aviation. Ash can damage aircraft engines, while lightning poses additional risks to electronic systems. This one-two punch can ground flights across entire continents, as we saw with the Eyjafjallajökull eruption. For scientists, volcanic lightning presents both opportunities and challenges. While it provides valuable data about eruption intensity and atmospheric conditions, it also makes field work extremely dangerous. Researchers must use remote sensing equipment and maintain safe distances while trying to gather crucial data. The electromagnetic pulses generated by volcanic lightning can interfere with radio communications and electronic equipment over vast areas. This can complicate rescue operations and emergency communications when they're needed most. Beyond the immediate dangers, the electrical activity can affect weather patterns in the region, potentially influencing rainfall and atmospheric chemistry long after the eruption has ended. Here's where volcanic lightning research gets truly exciting. Scientists are discovering that these electrical displays might be one of our best tools for predicting volcanic eruptions. This represents a complete revolution in how we monitor volcanic hazards. Recent research has revealed that volcanic lightning patterns can change dramatically in the hours and days before major eruptions. Dr. Corrado Cimarelli at Ludwig Maximilian University has been pioneering work showing that the frequency, intensity, and location of lightning strikes within volcanic plumes directly correlate with what's happening deep underground in the magma chamber. Traditional eruption prediction relies heavily on seismic activity, essentially listening for earthquakes that indicate magma movement. But lightning detection adds a completely new dimension. While seismometers tell us what's happening underground, lightning tells us what's happening in the eruption itself, providing real-time data about eruption intensity and behavior. The breakthrough came from studying Iceland's volcanoes, where researchers noticed that lightning activity often spikes dramatically 12 to 24 hours before major explosive phases. At Eyjafjallajökull, lightning detection networks recorded patterns that perfectly predicted the eruption's most dangerous periods, information that could have been crucial for aviation safety. Controlled laboratory experiments are revealing exactly how different types of magma create different lightning signatures. Silica-rich magma, which tends to create more explosive eruptions, generates distinctly different electrical patterns than basaltic magma. This means scientists might soon be able to predict not just when an eruption will intensify, but what type of hazards it will create. The Global Lightning Detection Network now includes specialized sensors designed specifically for volcanic lightning. These systems can detect electrical activity from space, allowing for 24/7 monitoring of volcanoes worldwide. When combined with traditional monitoring methods, this creates an unprecedented early warning capability. This research has immediate practical applications. In regions like Indonesia, the Philippines, and Central America, where millions of people live near active volcanoes, lightning-based eruption prediction could provide crucial extra warning time. Even a few additional hours of warning can be the difference between successful evacuation and catastrophic loss of life. The next frontier involves artificial intelligence systems that can analyze lightning patterns in real time, automatically identifying signatures that indicate impending eruptions. These AI systems are being trained on decades of volcanic lightning data, learning to recognize patterns that human observers might miss. Today's scientists are using incredible technology to unlock the deepest secrets of volcanic lightning. Lightning detection networks can now track individual strikes in real time, providing unprecedented data about the electrical activity within volcanic plumes. But the technology is advancing at breakneck speed. Quantum sensors are now being deployed near active volcanoes, capable of detecting electrical field changes so subtle they can predict lightning strikes minutes before they occur. These sensors can map the three-dimensional electrical structure of volcanic plumes in real time, revealing how electrical charges build and discharge throughout the eruption column. Machine learning algorithms are revolutionizing our understanding by finding patterns in volcanic lightning that humans never noticed. These AI systems have identified electrical signatures that correlate with specific types of magma composition, eruption intensity, and even the likelihood of pyroclastic flows, the deadly avalanches of hot gas and rock that represent volcanoes' most lethal weapon. International cooperation has created a global network of volcanic lightning monitoring stations. Data from eruptions in Iceland immediately informs monitoring systems in Indonesia, creating a worldwide knowledge base about how volcanic lightning behaves under different conditions. This collaborative approach is accelerating discoveries that would have taken decades working in isolation. High-speed cameras capable of capturing millions of frames per second are revealing the intricate details of how volcanic lightning forms and propagates. We can now see the step-by-step process of electrical discharge in ways that were impossible just decades ago. Advanced computer modeling is helping scientists predict when and where volcanic lightning is most likely to occur. These models could eventually help improve early warning systems and aviation safety protocols. Some researchers are even creating mini volcanic eruptions in laboratories, using specialized equipment to simulate the conditions that produce lightning. These controlled experiments are helping us understand the fundamental physics behind this phenomenon. This research isn't just academic curiosity, it has real-world applications for hazard prediction and emergency preparedness. The better we understand volcanic lightning, the better we can protect communities living near active volcanoes. Volcanic lightning represents something profound about our planet. It's a reminder that Earth is still very much alive and actively shaping itself. These spectacular displays are windows into the incredible forces operating beneath our feet. Interestingly, scientists believe similar phenomena might occur on other planets with volcanic activity. Some researchers speculate that the lightning detected in the atmospheres of Venus and Jupiter might have volcanic origins, making Earth's volcanic lightning a key to understanding atmospheric electricity throughout our solar system. Studying volcanic lightning also helps us understand how major eruptions affect global climate. The electrical activity within volcanic plumes provides clues about particle size, distribution, and atmospheric interaction, all crucial factors in predicting climate impacts. It's a perfect example of how different Earth systems, geology, meteorology, and atmospheric physics, interact in complex and sometimes spectacular ways. The ground literally reaches up to touch the sky, creating electricity in the process. From the ancient Greeks who thought Zeus was hurling thunderbolts to modern scientists using satellites and supercomputers, volcanic lightning continues to inspire awe and drive scientific discovery. These violent spectacles remind us that we live on a dynamic, powerful planet where the forces of creation and destruction dance together in ways both beautiful and terrifying. The next time you see footage of a volcanic eruption crackling with electricity, remember, you're witnessing one of nature's most incredible performances, where Earth itself becomes a generator capable of summoning storms from stone and ash. What other natural phenomena would you like us to explore? Let us know in the comments below, and don't forget to subscribe for more incredible stories from our planet's most extreme environments.